So in the different forms of work transfer, we are having first one as electric work, which is given by W is equal to integration from 1 to 2 EI dt, where I is the current flow in amperes and it is the rate of change of charge. C is the charge in coulombs, E is the voltage potential. Then another one is the important work as far as the mechanical work is concerned. It is integration of 1 to 2 T into d theta. That is, now if you differentiate this with respect to time, then rate of change of work is nothing but power. Torque is a constant and rate of change of angular displacement is nothing but the angular velocity. So shaft power is W dot, that is equal to T into omega. Pedal wheel work, so that will be given by mg into dz, the amount by which the work is, the component is moving in the upward direction against the gravity. That is the pedal wheel work or steering work. Then flow work, which is important for flow of the fluid from one place to another place. So where P is the pressure in kilonewton per meter square and V is the volume, specific volume in meter cube per kg. So displacement work is given by integration of P dV. Limits are from 1 to 2. So this is the flow work. Now, as far as the first law of thermodynamics is concerned, it can be applied to the cyclic process as cyclic integral. So cyclic integral of heat transfer is equal to cyclic integral of work transfer. For a process, it is also equal to heat transfer is equal to work transfer plus change in internal energy. So capital E is the total energy, and if only internal energy is considered, neglecting the other forms of energy, that is potential energy, change in potential energy, change in kinetic energy, etc., then Q is equal to W plus delta U, where U is this internal energy, delta U is change in internal energy. So delta E was the total change in energy, but out of this total change in energy, we are considering only change in internal energy. Therefore, delta E is replaced by delta U, or you can write down plus delta kinetic energy plus delta potential energy and etc. Sign conventions which we have used for heat and work is that when heat is supplied to the system, it is considered as positive. As you can see, heat is supplied to the system. When heat is rejected from the system, as you can see in the next figure, heat is rejected from the system, it is considered as negative heat. When work is supplied to the system, it is considered as negative work, and when work is obtained from the system, it is considered as positive work. In an internal combustion engine, during the compression stroke, the heat rejected to the cooling water, so this is important, heat rejection process is there, so heat rejected is considered as negative, just now we have seen, to the cooling water is 50 kilojoule per kg and work input is 100 kilojoule per kg, and work is supplied to the system. So when heat is rejected and work is supplied, both these quantities are negative quantities. Calculate the change in internal energy of the working fluid, stating whether it is a gain or loss of the energy. So heat rejected is Q, that is minus. Negative sign is used because heat is rejected. Similarly, work is supplied to the system, therefore it is considered as negative work. And we know that Q is equal to delta U plus W, where delta U is U2 minus U1 because it is a state function. So we can say that Q is minus 50, U2 minus U1 we have to find out, and work is minus 100. So U2 minus U1 will be equal to minus 50 as it is. Transfer this minus 100 on the other side, it will become plus. So it is 50 kilojoule per kg. And as this value is positive, we can say that there is gain in internal energy of the system.